Friends, welcome back to my channel. In this session we will see the functional description of this GREE 1.5 ton inverter AC indoor unit board. How it works, let's see in detail. If you see a refrigerator, freezer, it have compressor, condenser and a complete cooling cycle. To maintain the temperature in the cabinet, there is a thermostat switch. The basic role of thermostat switch that receives the temperature information within that cabinet and we set our required temperature. That thermostat will compare my required temperature and the present temperature in the cabinet, and it will decide if the temperature is above than my required limit. It will turn on the compressor to start cooling cycle. It will start cooling so that the temperature will come down. When it will come down, it will cool down at minimum threshold. It will turn off the compressor. So it will maintain the temperature within that limit, my required limit and the present temperature. We can say 1 or 2 degrees plus minus. If I need 20 degree, maybe it will maintain from 19 to 21 degree. At 21 degree, when the temperature will exceed, it will turn on compressor. When it will reach at 19, it will turn off the compressor. This is the theory. Similar to that thermostat switch, which is manually adjustable, it is electronic thermostat. So we can say it is similar to that thermostat switch. It has some additional features. What are that? The thermostat in the refrigerator, that is manual. Here we have remote control sensor. In the refrigerator we have high, low, medium, but here we can adjust temperature as per our requirement. Because it is air conditioning the room, it have blower fan. For that purpose it have blower fan motor connection here, and it will check the feedback from the blower fan, either the fan is rotating or no. If the fan motor will rotate, it will take feedback. In normal split units there were relays for speed selections, but in this board there is no relay. Here is K3 solid state relay. Processor will adjust the speed as per our requirement, which we set from here: fan speed, fan low, medium, high or auto. Fan speed will adjusted through this solid state relay, its driver transistor, from the microcontroller and from zero cross detector. Because it is using microprocessor, to power up the microcontroller, it have power supply section, that is low voltage power supply. The same in split unit, there was a transformer, but here it is using electronic control. To sense the room temperature, it is using NTC here. It is negative temperature coefficient resistance. And to check the cooling, either the compressor is working or not, it have this tube temperature sensor. It will sense ambient temperature, the air temperature in the room, and it will sense the cooling. Here is display, and here is swing motor, lower motor. It will move the flappers to direct the air in any direction. Thermostat switch in the refrigerator, when the temperature will become down, its contacts will make and it will start the compressor. Similar here we don't have electromagnetic contacts or relay. Processor will use these optocouplers. These optocouplers will send command by means of electronic signal. It is called communication signal. It is bidirectional communication. Anytime the processor want to send command to the outdoor unit, it will use one optocoupler and it will send the command. And if the outdoor unit will send any data, any status command to this processor, it will receive from this. And if there is any error, because it is electronic controlled and its all items are electronically operated, so if there is any malfunction, to protect from any damage, further damage, there is special code that is displayed here. Here we have neutral connection. Here is line connection. Phase and neutral. Two connections are coming from outdoor unit. Main power is supplied to outdoor unit. From there, these two wires are coming here. The third wire, that is communication wire. This capacitor for fan motor. Neutral is applied here. It is connected to this fan capacitor. Fan capacitor's second end is reaching here at this point, and it is connected at connector. Line terminal, that is reaching here, then it is coming at this point. Here is fuse. Fuse second end is coming at this point. After fuse, it is one end is reaching here. It is filter for this K3 solid state relay that will drive the fan motor. Here is coil, here is capacitor. When this solid state will receive command, it will switch the voltage. At that time, it will pass these voltage from here, fuse, here, from this filter, here to the fan connector. When fan will rotate, it will give digital pulses feedback to this connector. At the same point, from fuse, then we have here, it is NTC, negative temperature coefficient resistance. It is for protection of surge current. After that, this point, it is reaching here. We have filter here, EMI filter, neutral and line. Then it is reaching here. Here we have resistors. Then these both lines are reaching here to the bridge rectifier. And from same this point, it is coming here. It is zero cross detector. U31 and U7. These are zero cross detectors. It will provide DC voltage here at this capacitor. Then here we have TNY277 IC. It is offline switcher. Resistor, capacitor and diode are CD snubber. This VCC capacitor, and this is auxiliary voltage rectifier. Positive voltage will reach here at this point of the winding. Negative are reaching here to the IC source pins. When IC will switch, it will pass the switched voltage to this point. It will produce magnetic field, positive, negative. At positive, we have one resistor here. From this point to here, and it is reaching to this VCC capacitor or startup circuit. It will provide voltage here. This IC will start switching. In the second side, we have this winding, that is output winding, and this winding, these 2 points, these are for auxiliary winding. This end of the winding is connected to primary ground, that is here, and this is connected to rectifier. It will rectify and we will receive voltage at VCC capacitor. Then we have this optocoupler. This optocoupler will switch when the output voltage are obtained here. It is using TL431, that is here. We will receive 12 to 15 volt at this capacitor, and then we have 7805 regulator. This regulator, it is important for this microcontroller and all other ICs. 12 volt supply for ULN2003, this one, and to operate this relay, 5 volt signal is used to operate our memory IC processor, and it will also bias up these sensors and display. Here we have transistors for display as a display driver, these transistors, and we have this IC to drive the digits. Processor will send all commands to this ULN2003, it will drive these segments here in the display. When we want to drive the flappers at that time this microcontroller sends command to this IC and it will drive swing motor up down. Then we have K5 relay. In the first step, the processor will turn on. When it will turn on, at that time it will turn on this relay. From here, when it will turn on, it will pass these voltage here to these rectifiers, that is here this rectifier, and it will provide biasing voltage to this optocoupler. It is for transmission. When the processor will need to send data to outdoor unit, at that time it will drive this optocoupler. It is TLP785. In receiving mode, it will use PC817. When the outdoor unit will send any data, it will receive at PC817. When it will send data to outdoor unit, at that time it will use this optocoupler. Its input side is at processor side and its input side is connected at communication port, that is here. Then there are different test points in the board for temperature, for voltage. At each test point there are special markings. For example, here is zero detector test, zero test, remote test, 12 volt test, 5 volt test. How this zero crossing detector works? It is sine signal, that is input signal. This zero crossing detector will send information pulse from here. At each zero cross, it will send pulse to the microcontroller. PC817 here, it will provide the availability of the voltage. That voltage are within limit. That is a small optocoupler. And this one, it will provide these pulses here. It will provide information to the processor. So when the processor will try to adjust the speed, it will use command signal to operate this solid state relay. For example, if we need slow speed, it will allow just only, for example, this portion. It will give trigger signal. Here is zero signal. It will delay until the signal is here. So in the output we will receive this signal. Same here. This portion, it will become in the output. If you want to turn on at medium speed, maybe processor will wait until here and then it will give signal pulse to the TRIAC, to the solid state relay. At that time we will receive output like this. Same in this half portion. At that time fan motor will spin up with more speed with compared to this speed. This is low, and if we need high speed, full speed, maybe the processor will send signal at this point and we will receive complete half cycle in positive side and negative side. So fan will spin with maximum speed. This zero crossing detector will provide information that what is the current position of the sign. Based on its signal, this microprocessor will calculate and it will give drive signal to this transistor and it will drive this solid state relay that is covered under this metallic cover. When it will turn on its TRIAC and its TRIAC will switch these voltage to the output terminal. For example, if we turn it on and it has something wrong in the board, it is not spinning the motor, if the feedback is missing for a specified time, at that time it will generate error code. So let's power it on. If you don't have good experience in electrical circuits, never try to test, never try to repair, and we will monitor the communication signal as well. Line voltage here, neutral here. If you are using oscilloscope, use isolation transformer, and always take care for the safety. When you are testing communication signal, never touch these ports. Always take care for the safety. I will connect common at neutral, and I will connect high side at communication out. I adjusted probe to 10x. Now I will power it on. You can see the board powered on, and it sent some signal to the outdoor unit that power off. Now I will power on. I set temperature to 18. Now the processor started and it sent some signal to outdoor unit, and it turned on this relay. It is waiting for the communication from the outdoor unit, but it is not receiving any feedback, any command, so it is trying again and again. After that, it will generate error code for the communication. It will try for multiple times with specified time intervals, and it is also giving H6 code, that is feedback from indoor motor is failed. Here it is providing voltage to the fan motor, but there is no fan motor. When there is no fan motor, we will not receive any feedback here. Let me power it off. I will disconnect oscilloscope now. If you have bad optocoupler, at that time it will not send this signal to outdoor unit. Now I will apply power. There are jumpers here. We can also test voltage from these jumpers, but this time I will check voltage from the rear side. First we will set DC voltage common and this communication pin. When it will send signal, multimeter will show 97 volt. $12 volt. At this capacitor we have 5 volt. From this point 12 volt are supplied to this IC and this IC. Here are many transistors. TL431 is here. All transistors are SS9013 or BR9013. This transistor drives this as solid state relay. One transistor out of this IC, it will drive this relay, that is communication relay. It will take drive from this pin. From this IC, this pin, it will drive this relay. Then these thermistors, these will provide variable resistance value with compared to temperature. When the temperature is high, its resistance will decrease because it is 15K NTC, 15 kilo ohm negative temperature coefficient resistance, that is between these 2 points. This time it is giving 6 kilo ohm. When the temperature will increase, now I will hold in my hand. We can see the resistance is decreasing now because I am holding it in my hand. 5.869. Now I will leave it. Now the resistance will return back to normal. The same this sensor, that is in the second side. You can see the resistance is decreasing. When I will leave it, now the resistance is increasing. So this resistor value, one end from one sensor, one end from the second sensor are connected to same line, but output of these is connected to this resistor, and here second sensor is connected to this resistor, and its value is coming to the microcontroller, and its value is also coming to the microcontroller. So these resistors are making voltage divider network. One resistor have stable value, the second is varying. At that time there will a voltage difference. That voltage difference will translate the temperature value. So this microcontroller will compare our required reading and the present temperature. So it will send signal to the outdoor unit to turn on or turn off the compressor. If there is any malfunction, there is any problem, if there is any error, at that time it will stop the operation and it will display error here. Some most common problems here, that are these optocoupler. It is communication error. Sometimes we have high side TLP785 optocoupler. That is most common failure item. And in some conditions, when the fan motor is not running, spinning up, at that time this solid state relay SSR becomes problematic. That is here. It is R3 BMF 51. So it is trike based solid state relay. One side it have sine signal, line voltage, but it will switch as per command provided by the processor. The processor will know information, the starting sine wave of 60 Hz signal from these zero crossing detectors, and then it will decide to turn on the output that is reaching here through this filter here, and this is output point. It will provide line voltage, switched line voltage, the clipped sine wave signal in the output, neutral here, line voltage here, and this capacitor will provide torque here at this pin. Capacitor at this pin, neutral, line. Sometime we can find diagram for these boards, and some companies are not providing diagrams. Even if you can find diagram or we cannot find diagram, the same. If you understand the circuit, then there is no need for any diagram. Most of the circuit boards are same. Here is 2K serial EEPROM 256x8. It is 24C02. It stores the data. Processor stores the data and it receives back data from here, from this IC. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching.